Hi viewers, this is I'm Samahadri, lecturer in statistics. Today I'm explaining one of the important theorem in probability that is called addition theorem for n events in probability. Right? So this is the one of the main important theorem. So the statement of this theorem is for n events, right? For n events a1 comma a2 comma and so on an. There are events a1 comma a2 and so on an. We have p of union I running from 1 to n ai is equal to summation I running from 1 to n p of ai, okay, minus summation double summation adding what I not equal to j equal to 1 to n, okay, p of ai intersection aj plus triple summation I not equal to j not equal to k equal to 1 to n p of ai intersection aj intersection ak, okay, minus and so on minus 1 whole to the power of n minus 1 into p of intersection I running from 1 to n ai. This is the statement of Edison theorem for n events, for probability for n events. Okay, so now the proof of this theorem. Now proof of this theorem is so we can prove this theorem by using a principle of mathematical induction, right? So we can prove this theorem by the principle of mathematical induction. We can prove this theorem by the principle of mathematical induction. So everyone, you know that principle of mathematical induction, there are three steps. The first step is you have to prove that n is equal to 2, and second step, let us assume that n is equal to r, and the third step, you can prove the theorem is you can prove the result is n is equal to r plus 1. Three steps. The first step is for two events, right? For two events a1 and a2, for two events a1 and a2 comma we have for two events a1 comma a2 we have two events, that means p of a1 union a2. This is the addition theorem for two events. So what is the formula? P of a1 plus p of a2 minus p of a1 intersection a2, right? That is p of this is union I running from 1 to 2, right? ai is equal to, this is p of a1 p of a2 plus symbol. This indicates that summation, okay, I running from 1 to 2, this is p of ai, okay, minus plus this is right as minus 1 whole to the power of 2 minus 1 to p of intersection I running from 1 to 2 ai. What is that? Minus 1 to whole power 2 minus 1, 2 minus 1 is 1, minus 1, so plus minus minus, so minus p of a1 intersection a2. Then there is the intersection I running 1 to 2 ai. So observe that the state compared to our statement and this result. So see this I running p of I is equal 1 to 2 ai is equal to I summation I running 1 to 2 p of ai plus and so on minus 1 whole to the power of n minus n means the place of 2. So 2 minus 1 into p of intersection I is equal to 1 to 2 ai. So therefore our result is true for n equal to 2. Okay, hence hence the theorem is true for the theorem is true for the theorem is true for n equal to 2. Very simple, n equal to 2. Next, this is second step. What is second step? Let us suppose that let us now suppose that let us now suppose that let us now suppose that the theorem is true for the theorem is true for n equal to r. Let us now suppose that the theorem is true for n equal to r. Therefore p of union I running from 1 to r ai is equal to summation I running from 1 to r ai. Okay, so this is also same as given statement. Okay, in the place of n putting r. Okay, summation I running 1 to r ai minus double summation I not equal to j equal to 1 to r. Okay, onto this is p of a, sorry, this is p of a into p of ai intersection aj and plus triple summation I not equal to j not equal to k 1 to r p of ai intersection aj intersection ak minus and so on whole to the power of minus 1 whole to the power of r minus 1 into p of intersection I is equal to 1 to r ai, right? This is equation number this is also equation number 1. This is equation number this is equation number 1 and this is equation number 2. Okay, so now the third step of this theorem, on the third step we have to prove that, right? Now we have to prove that now we have to prove that the result is true for the result is true for n equal to r plus 1. Okay, now consider the left hand side p of union I is equal to 1 to r plus 1. ai is very important. I is equal 1 to not r plus 1. 1 to r plus 1 ai is equal to, okay, this can be written as p of this is union I running from 1 to r ai and union, this is union AR plus 1. How can it possible? It's very simple. See this, there are totally 1 to r plus 1 terms is there, right? 1 to r plus 1. Now this term is r, 1 r plus 1, right? So now I am taking 1 to r is one term and remaining term is r plus 1. So union of I running 1 to r ai union er plus 1 is very simple, right? So this is equal to the from equation 1. So what is the from equation 1? What indicates that? Equation 1 is p of a1 union a2 is equal to p of a1 plus p of a2 minus p of a1 intersection a2, right? See this, p of a1 union a2, p of a1 union a2. From equation 1 to write that p of union I running from 1 to r ai plus p of ar plus 1, p of a2 minus p of a1 intersection a2. So p of a1 means I running from 1 to r ai intersection ar plus 1. Okay, now since from 1, from equation 1 from equation 1, p of a1 plus p of a2 minus p of a1 intersection a2, right? So now I'm writing that that is equal to p of union I running from 1 to r ai plus p of a r plus 1 minus, by using distributive law, that means this is the p of union I is equal to 1 to r, this is ai intersection ar plus 1, right? By using distributive law, distributive, what is distributive law? Very simple. So this is union I want to or a, that means a1 union a2 union and so on ar. Okay, so bracket intersection ar plus 1. I am taking a1 intersection ar plus 1 union a2 intersection ar plus 1 union and so on ar intersection ar plus 1. So combination of unions, the union iron 1 to r a intersection r plus 1. This is called distributive law. Okay, so now I am taking observe that the first term, that is p of union I is equal to 1 to r a, from observe that equation 2 in this theorem. So what is that? Equation 2 indicates that p of union I running from 1 to r a is equal to, this is the expression for p of union I running 1 to r ai. So now I'm writing this expression in this place of first term, that is equal to what is that? First expansion, the summation I running from 1 to r, okay, p of a I minus double summation I not equal to j equal to 1 to r p of a I intersection a j, okay, plus and so on plus minus 1 whole power of r minus 1 into p of intersection I running from 1 to r ai. This is the first term, right? This is the first term plus second term is p of ar plus 1, right? P of ar plus 1 minus third term, I'm writing as it is that term, it is p of union I running from 1 to r a I intersection ar plus 1, right? So now I'm taking first term in the expansion. So I running 1 to r p of ai, this is p of ar plus 1, this both are adding. So we can written as summation I running from 1 to r plus 1, right? P of ai minus double summation as step is as usual, I not equal to j equal to 1 to r p of ai intersection aj plus and so on plus minus 1 whole power of r minus 1 into p of intersection I is equal to 1 to r ai. Okay, so this is the first term, and minus I'm writing this expansion. So see this, the last term of this expansion. So observe that union I running 1 to r, I think this is all considered as ai, for example ai. So up of union I is equal to 1 I running from 1 to r ai. So what is that? From equation 2, is very easy, to understand that union I running from 1 to r ai. So in the place of ai and r plus 1. So I am expansion that summation I running from, I will expand that I running from 1 to r p of first term ai intersection ar plus 1 minus, right? So somewhere around 1 p of ai. Okay, next minus double summation I not equal to j equal to 1 to r p of ai intersection a j intersection a r plus 1 intersection a r plus 1. Okay, plus and so on plus minus 1 whole power of r minus 1 into p of intersection I running from 1 to r a I intersection a r plus 1, right? This is the expansion of the last term. Okay, so now it is equal to summation I running from 1 to r plus 1 p of ai, right? Minus the combination of two terms, double summation I not equal to j equal to 1 to r p of ai intersection er plus 1, whereas summation I running from 1 to r p of ai intersection er plus 1, the one combination. So combination of two terms. So this is the term and this term, right? So plus and so on plus minus 1 whole power of r into, so p of intersection I running from 1 to r plus 1, this is ai, right? This is the answer. And last step of this theorem is that is equal to, what is that last term? P of, right, p of union I running from 1 to r plus 1 ai. Okay, ai is equal to summation I running from 1 to r plus 1 p of ai minus double summation, okay, I not equal to j equal to 1 to r p of ai Okay, this is r plus 1, sorry, this is r plus 1, a intersection aj plus and so on plus minus 1 whole power of this term also is r plus 1 minus 1, right? So p of intersection I running from 1 to r plus 1 ai. Observe that the statement, so I running from 1 to n ai is equal to I running 1 to n p of a minus I running from j I not equal to j equal to 1 to n plus 1 n p of a intersection aj plus and so on minus 1 whole power of n minus 1 into p of intersection I is equal to 1 to n ai. So therefore our theorem is true for n is equal to r plus 1. Therefore the theorem is true for therefore the theorem is true for n equal to r plus 1 events. Hence by the principle of mathematical induction, hence by the principle of mathematical induction, the theorem is true for all positive integral values of n. All positive integral values of n. Okay, this is the addition theorem for n events count theorem. Okay, this theorem is very important in your semester examination. Okay, tomorrow next class we have to meet again. Okay, the new concept. Okay, have a nice day. Bye.